Hello, hello, honors geometry kids. I feel like I have not seen or talked to you guys forever. It's been a while since I've done a video. Anyway, hopefully you all did well in your test. Today we are starting our very last unit, which is on circles. And I'm going to go through this fairly quickly because as you can see, there's a lot of slides on the left-hand side. So a lot of this stuff is review, some of it's new. So I'm going to start with a chord. So what is a chord? A chord goes from one side of the circle to the other. So example, in this problem, XS and WV are both chords. And the radius you guys should know, the diameter you guys should know. The radius goes from the center to the outside. The diameter goes all the way across through the center. So I will go back and fill in these notes and you'll find the notes on your Google Classroom. Okay, next, what is a tangent line? Up top it tells you a tangent line goes through the circle and hits at one point. So this right here is a tangent line from H to D. That is a tangent line. A secant line hits at 2 points. So like FK is a tangent line. There's FK. And then there's lots of different chords you could say. You could say EG, IG, IE, etc. Okay, moving right along. All right. How do you find the circumference? So you guys should know circumference. In case you forgot the formula, I put it on there. Circumference is pi times diameter. So in this case, the circumference, oops. Gotta go back to my pens. So the circumference in this problem would be pi times 16. And they say to use 3.14, so it'd be 3.14 times 16. And then that would be your circumference, and it says do not round. So make sure you do not round. Okay, next. It talks about, okay, now here's some new stuff. First of all, an inscribed angle. What is an inscribed angle? An inscribed angle has its vertex on the circle. So, for example, and its sides intersect the circle. All right, so this right here would be what's called an inscribed angle. So that would be angle BDE for inscribed angle. Okay? And that is because the vertex is on the outside of the circle. And there we go. Because the vertex is on the outside of the circle and the sides connect with the circle. So BDE, or you could also say EBD. All right, next, what is a minor arc? A minor arc is less than 180 degrees. Okay, so what is an arc at all? All right, when you have a circle, okay, this right here is called a central angle because here's a central angle up here. It says a central angle is an angle whose vertex is on the center of the circle. So if I say, let's say that that is 60 degrees. If that is 60 degrees, this is also 60 degrees. So that is called a minor arc because it's under 180 degrees. Exactly 180 degrees would be a semicircle, and a major arc would be over 180 degrees. All right, so in this problem, we have the inscribed angle. The minor arc, there's a bunch of minor arcs. We could say that a minor arc would be BE because that is under 180 degrees. For part B, we could also say that DC is a minor arc, and you put an arc above it. Okay, next, part C, the semicircle. For the semicircle, if you notice that E or BD is a diameter, so that means that if you do the top of the circle or the bottom of the circle, that would be your semicircle. So for part C, you need 3 points because you need to say whether you're doing the top half or the bottom half. You can't just say BD because I don't know if I'm going on the top or on the bottom. For a minor arc, you only need 2 points. For a major arc, you do need 3 points to show that it's a minor arc, a major arc versus a minor. All right, so for the semicircle, we could say B, E, D, and that would be the top half. Or we could say the bottom half, which would be B, C, D. And that would be the semicircles. All right, next, BC, it says, what is the measure of arc BC? All right, well, that one's actually not too bad because if this is 115, guess what this is? the same thing, 115. And then it says, what is the measure of BCD? All right, well, BCD goes from here all the way to here. Well, that's a semicircle. So that would be 180 degrees because that is half of the entire circle. It's a semicircle. So this would be 180 degrees. Okay, moving on. All right, for this one. All right, so if you were going to make a circle graph, how many degrees should x be? Well, in the entire circle, you would have 360 degrees. All right, so we know that the part that I'm looking for sociology would be x out of 360. So then I just set up a proportion. I say, okay, well, sociology is 99. That's going to coordinate with the number of degrees. So then I would just add all those up, and whatever this total is going to go right there. And then you would just cross multiply. So you take 99 times 360 and you divide it by the total number of sorority members. All right, now I will have this all done in the notes if you want to look at the notes, but I want to finish this in the 15 minutes. Okay, moving on. Okay, so it says, what is the length of major arc QSR? Okay, so QSR. So that is a major arc. How do we know that's a major arc? Because it's greater than 180 degrees. Okay, so that's why it's called a major arc. If we were doing a minor arc would be QR. So if there's only 2 letters, it's the minor arc. If there's 3 letters, that's the major arc. So that's another way to tell the difference between a minor and a major arc. So this is just like extra information right there. Okay, so we want to figure out the length. We know the degrees. We know the measure of QSR is going to be equal to 360 minus 170 because there's 170 degrees in a circle. So we know the measure, but they are actually asking for, okay, what is the length? Okay, so once again, we are going to set up a proportion to solve this because we can find the entire circumference of the circle. The circumference of the circle is 2 pi r, 2 pi r, that's supposed to be an r. And we know the radius is 4, so we know the circumference is 8 pi of this entire thing. Well, we can figure out what proportion the major arc is. So the major arc is 360 minus, 170, which is 190. So that's going to be 190 divided by 360, okay? Now, this is the entire circumference of the entire circle. So if the entire circumference is 8 pi, then what is just the major arc length going to be? Well, I'm just going to put an x here, and that is going to be my answer. So I'd cross multiply. So I would take 190 times 8 pi, leave the pi as pi. So you just take 180 times 190, times 8, and then you would simply divide that by 360. So 190 times 8, I'm going to go and do this calculation, divided by 360, I'm getting 4.2 repeating. So that would just be 4.2 repeating pi. And you can change that into a fraction. It's 38 over 9. So in this case, x would equal 38 divided by 9 pi. Okay, and you can use your that arrow button on the white calculator to change it from a decimal into a fraction. If you don't have that, you're just going to have to simplify the fraction. And the units would be meters, because you can see that it is in meters. So that would be 38/9 pi meters long. Okay, next. All right, so for this one, As you can see, SQ is a radius, and SR is also a radius. So we know that SQ and SR are the same length. Now, when you have a chord, as you can see, hopefully, if you remember, JK is a chord. All right, JK is a chord. If a chord is perpendicular to the radius, it splits the sides in half. So that means that KN is congruent to NJ. So that means they're the same length. Also, over here, same thing over here, LP is congruent to PK. I think my writing would get better, but I think it's actually gotten worse. Sorry. All right, KN. All right, so if we know that SN is 12 and SP is 12, they tell us that JK is 19 and LK is 3x plus 1. All right, well, JK and LK, all right, so SN is 12. And this is 12, which means that these two chords are going to be the same length. Because if this and if, you can't see what I'm pointing to. So if this and this are the same length, that means these two chords are the same length. Therefore, I know that 3x plus 1 is equal to JK, which is 19. So 3x is going to be equal to 18. So x is going to be equal to 6. So if x is 6, then let's see. So x is 6. And they also want to know the length of JN. Well, if JK is 19, then JN is going to be half of that. So it's going to be 19 divided by 2, or 9.5. Okay, nice. And you can pause these as I go. Okay, 2 left. These are both going to be dealing with a squared plus b squared equals c squared. So make sure that you keep that in mind. All right, so you know that OT is 9.9. We know that SU is 13.2. All right, so in this one, if you have 2 points that are tangent to the circle, so this is tangent to the circle, and this is tangent to the circle, and those 2 points meet up at point S, or those 2 lines converge to S, that means that this length is going to be the same. So this is going to be 13.2. All right, if it's tangent, that means that this is a right angle. So that means that this right here is a right triangle, which means that 13.2, oops. I almost wrote the squared and I hadn't finished writing the problem. So that means that 13 point, oh my goodness, I did it again. Sorry. Okay. So 13.2 squared plus 9.9 squared is going to be equal to OS squared. And I'll let you guys finish that. Okay, last one. I got a minute left here. All right, so IL, they tell you that, no, IJ is 4.5. And they tell you that JL is 2.8. So this is tangent, so it's a right triangle. So we know that 4.5 squared plus 2.8 squared is equal to IL squared. Well, once you find IL, this whole length is IL. Well, this is tangent to the circle, and this is tangent to the circle. That means that if this is 4.5, this is 4.5. So once you find IL, you simply subtract 4.5 from it, and that's going to equal KL. All right, it wasn't pretty. It's a little bit messy. I'll clean it up and post the notes. And we're going to finish up here right under 15 minutes. So have an awesome Memorial Day weekend. Although I'll have another video on Friday, so never mind. Anyway, all right, so have an awesome week, and I will chat with you guys later. Okay, bye.